Hey folks, welcome back. This is already the 10th episode, so pretty cool, pretty cool. This time we will do things a little different. First of all, I'm trying out like a slightly different microphone setup. So trying to go without a pop filter, which should allow me to see more of my keyboard and just make life easier for me, while sitting a bit further away from the microphone, so just let me know if this is completely unlistenable. I hope it will be alright. Another thing is that today we'll be doing a little bit of research and development for the crane. And we'll probably actually write quite a bit of C++ today. The reason for which will be apparent in a bit. You might also notice that we are in slide currently, not in means. The reason for that is that I have this prototype crane thingy here, which I want to talk about a little bit. Let's go pick one of these guys up. We can mess around with this. So this is a one of these futuristic attractor cranes, which I sort of feel like the mother vehicle should also have. This is not the crane that we're going to tackle first, partly because I have kind of solved this problem, at least to a certain extent. I'm kind of more interested in a traditional physically based crane. This is also physically based to a point, but so this is what it does. You can only see like this very faint sphere here. If I lift it up and then I turn off the sky for a bit, let's see. Boo! Now you should be able to see it. So that is the attractor, as I call it, and you can move the attractor like essentially like forward, backwards. You can turn the crane by just moving the camera, and you can move it up and down. And if I enable the attractor, you can see that it starts just sucking these things in, and they essentially just form like a ball around the thing. So the idea with this is that you can essentially collect dynamic objects, and this is also going to be a thing in means. And this is kind of fun and interesting to play around with. You can also do things like, while this is hanging there in the air, you can just start to drive around, and this can lead to some interesting cases where the attraction force isn't quite strong enough so that it starts to scatter them around like this. All fun and games. Of course, from like a gameplay perspective, the reason we have this is that it's just much easier to have this sort of magnetic thingy when you want to actually lift up a bunch of dynamic objects. So this is kind of interesting. We can most likely take this and develop it further for means. But there's one kind of boring thing about this thing, and it is the fact that how should I explain this? The forces that act on these guys, they don't actually affect this crane at all. So if I just put down a vehicle here, or spawn a new vehicle, you can see that it sort of let's put something larger, maybe even. Well, yeah, the vehicle hit this guy, which meant that the whole thing sort of moved. But if you just put something down on this, well, this doesn't really have a body, but it also means that like if you're trying to lift something really heavy with this, the weight of these objects don't really affect this guy at all. So forces don't really go the other way around. The force from this attractor attracts things, but the weight of those things, for example, they don't affect this this trailer which has the crane at all, which I would sort of like to have, at least for the physically, shall we say, more accurate and realistic crane, the cargo crane. And I don't know exactly how I am going to solve that. Like the way this works is that we just have this body in the physics engine, which is this attractor, the sphere thingy that you saw in the middle of this mess of things. So that guy. And we simply move around that body as a kinematic object, kinematic body in the physics. So for it to be affected by other things, it would need to be dynamic, and that would mean that we would have to sort of anchor it to the body of the trailer using a joint. Currently, this is not done. So from a physics perspective, you have this guy here. Let's see if we can we like turn on. Well, we have actually server physics enabled. Yeah, we can't actually see that yet. But yeah, this has a dynamic body. So if you just drop something onto this, such as a vehicle, you can see like the suspension going like because it is actually like an actual dynamic body. But if you drop something onto, like you can't really make this move by dropping something onto it because it's a kinematic body. Perhaps that is the easiest way to tell it. And it would be very cool if when you're lifting something with the mother vehicle, if you're lifting another vehicle which is obviously relatively heavy, if the mother vehicle's suspension would sort of reflect that. I think that is, without that it would just look kind of weird and artificial, which is perhaps okay for like an attraction crane like this, but not necessarily like a magnetic cargo crane, so just the one that we're looking at adding to the mother vehicle. So I've started prototyping something, and I've done it in C++ currently, because yeah, it was right there. So proto crane component. The reason I do this in C++ is that I haven't exposed any physics joints to SIG yet. I will do that, but before I do that, I want to know sort of what will make sense in a way. So if we have a look at this guy. Actually, before we do that, let me just do something quickly. I'll show you what I mean. Create base physics. Let's put this position, make it a bit further to the right, something like this. And what? Yeah, that's not what I wanted to do. That's what I wanted to do. So this is essentially throwaway code, right? Because we want to do all of this in Zig, but I want to know what to expose to Zig before I start messing around with that. And let's set the correct project. So trampoline is the thing that kicks off means. And here we are in our well-known scene. So we don't actually have this component yet, I just realized. So let's just quickly add it here. We can copy the name. So proto crane component means, and we go to blueprints and to mother, and we add a new component. The component type is that. We need to give it a name. Let's give it a name. I typically leave out the component from the name. Okay. It tells us that it's not a registered component type. That's fine. We're still going to want to put it in. We want it on, I think it only actually does anything on the server currently, but we can have it on the client as well. like so. Right, so now, now if you go into the game, we have this thing here, which is currently just hovering over the body. Actually, we need to move it a bit further to the right still to prove my point. Oh, that was actually, what was that? What was it before? 0, 1, 0. Let's fix this. Okay, 0, 1, 0, and it should have moved actually, but it didn't. Why is that? Why is that? What? That's interesting. Okay, well in that case we can do something like this. Let's move that 10 to the right. Let's see if that actually fixes it. Yeah, arm end rigid body description. I'm gonna explain all of this just in a second as soon as I get it positioned the way I want it. Okay, so that's not doing what I expect. That's kind of annoying, but okay, that's probably fine. Where's that? 3, 5. This is probably at least partially to blame for it. Yeah, I'm having my math incorrect here because of operator precedence. Basically what I want to do is just move that thing off to the side of the vehicle, and now we have it. Here we go. Now it's just hovering here off to the side of the mother vehicle. But it is nested to the mother vehicle, so if we just move the camera away and then we start driving this guy, you will see that it sort of sits in the mother vehicle's sort of local frame of reference. And so you could imagine this now to be that attractor arm, attractor object essentially. The interesting thing with this now is that it is a dynamic object. So we can do this. We can just drive into this and it will actually bring the whole mother vehicle along with it. And now we're essentially stuck because got pinned down with this somehow. That's interesting. Yeah, let's get rid of this mother and create a new one, and it just explodes out of the wall. Yes, so now this object that you're seeing, which is hovering there, is no longer actually a kinematic object. It's a dynamic object, which means that it tries to stay where it is in the local frame and local space of the mother. Which means that it will also push the mother away. And this is now attached to the mother with a joint with a 6 degree of freedom, or DOF6 joint. And another interesting thing with this is that we can move it. We can have a motor which moves it further away, essentially. We can move this around and we can make the motor very, very strong. And that sort of can be compared to like you can see that now it's moving to the right. So you can sort of think of this as the motors for the crane. And it also means that like if we park the thing next to this wall here, sooner or later that thing is gonna hit that static object, which is it's a static object, so it's immovable. And when that happens, it should start pushing the mother vehicle away, just as if you had a very, very strong crane, which is kind of pushing away and you're sort of using it to like push into a wall of a building or something. You can see like the mother vehicle suspension just going like whoop, 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 and it tries to solve it, and it solves it by just going on top of the thing. And there we go. Now it just moves there. Okay, like sooner or later it's just gonna move over that thing, and then it's gonna fall down again. And so yeah, I think this is kind of interesting, because that means that now if we sort of drop something on top of this guy, it will affect the mother vehicle as well. You can just imagine that there being like an arm between these two objects, which we will put in then when we have this thing. When we have this thing a bit further developed. But I was thinking that we could take this prototype thingy and see how well it actually... So now it's going to fall down. Brr, there we go. Hey, and now it's on the other side. And it even moves slightly up and down with the suspension of the mother. So, yeah. Anyway, oh right, it just uses a global variable here, so it just like completely it like spawns inside that thing, and then it kind of sorts itself out over time. Right, so we could take this thing and make it so that you could actually control the position of that object, and then we could maybe connect like a cable to it, which hangs from it, and then we could add something to the end which will sort of act as the magnetic, the magnet really, and then we could even try to lift something up and see if that whole thing kind of works. And if that works, then we know that okay, this 6 degree of freedom joint is going to actually be the correct thing to use here. But let's have a quick look at what we have in this component. So this looks perhaps a little similar to the SIG components. At least I hope it should do that. So we have a class here. We have just this macro which enables this to be a component. On the C++ side, we have constructor, destructor. We have create and destroy, similarly to how we have it on SIG. Also on object created is similar. Update, tick, and on message received. These are like really the same methods. You can have them if you want to. If you don't have them, they won't be called, etc., etc. So very similar to SIG. Then we have some stuff here related to the actual arm end, is what I call this thing. So we have arm end shape, we have arm end rigid body, we have some descriptions for setting those up, and we have the arm end joint, which is a DOF6 joint, degree of freedom 6 joint. Degree of freedom 6 joint maps pretty directly onto the FysX degree of freedom 6. So we have these things here where we set up the motion. So the motion, both the angular and linear motion, can be locked, and by default everything is locked. So we actually set the motion here to be free along the X, Y, and Z axis, so it can move freely in the local space of the vehicle. And we set the drive, which actually allows us to move it to specific points. We set I think it is the what's it called? Yeah, stiffness is the first value, which I have ridiculously high. That's like 4 million of whatever the unit is there. What is the unit actually? It just says that it's the stiffness of the drive spring. Doesn't really tell me what the unit is. But yes, I set that very, very stiff, so it basically just like doesn't move unless you actually tell it to move from code. Then we have the damping is also pretty high, and then the drive force limit is also just very high. This doesn't necessarily need to be this high, or none of these necessarily need to be this high, but I've got a pretty good results with this. So that's how we can drive it. The way we create the physics is we currently create them only on the server, just to make things easy. We may or may not want to have this thing on the client, but currently we have them only on the server. And the way we actually can see the client vehicle like react to this is that since this is connected with a joint to the chassis object, the chassis rigid body on the server, and the server corrects the client over time through the network, we can actually see the client reacting to it as well. That may or may not be sort of good enough. We shall see. We want like a nicely animated cable from that crane. We might actually have to create all of this on the client as well. So we'll see. See how it turns out. Right, but anyway, when the object is created, if we are on the server, we create the base physics. Otherwise we said update needs update to true. We don't need that currently because we can see that update is just empty. And we create the shape, which is a cylinder. It's a very pretty small cylinder. We create a dynamic rigid body. It's not kinematic, that is important. Mass is 50 kilograms, probably quite light. Actually, this might have to be larger, but we'll see. I'm going to keep it as it is for now. And then when we have the thing added to the physics scene, we add the joint. We connect the joint to the physics actor of the transform. So this is essentially the chassis rigid body in this case. And we connect it at the base local position, which we just messed around with here to set the actual place where it will be attached, and then we connect it to, like, this is one body at that position, and this is this body at that position, and that is essentially it. So this is position, yeah. G base local position. Yeah, okay. So local position, yes. This is like where the thing will be in local space, right? Yeah. So that the basic local position is like under the thing, and then we move it up one unit, and that is where we will place the object itself. And this can get kind of confusing. So if we look at this one more time. Like in the code, POS is like in the middle of this guy, this cylinder guy, and G base local position is like 1 meter, so 1 world unit below it. That is where it is kind of fastened to the chassis. Okay. All right, let's get a bit of coffee and start hacking on this thing. So the first thing that we'll want to do, again, very much throwaway code, but code nonetheless that we will want to put into this guy, is we'll want to move it around. And I think actually what we'll want to do here is just make this an avatar tracking component. We've seen those in the on the SIG side, and they're quite similar here on the C++ side. I'm going to actually just move this up to the side and see how this goes. So rather than using a basis game object component, we're just going to use a basis avatar tracking component. So we'll derive this from avatar tracking component like so. And we need to do it here on this side as well. And that might be it. Actually, that's everything we need to do to to be able to use avatar tracking components. But now what we can do, the reason why I wanted to do this, is that we can add the pre-tick method here. And it just takes the tick time, same as tick. Pre-tick runs just before the physics is stepped. So let's put it here. And what we will need to do here is set it to set needs pre-tick. So you can have a tick function and not call it if the thing doesn't currently need it to be called. Where do we actually? Yeah, we set needs tick to true there in the create. Yeah, that's an okay place. So here in pre-tick, we probably actually want to set this this a drive goal pose where we can set the position in local space. In local space, we set the goal pose of the joint, and the joint is anchored. This is the first actor in this local position. Yes. So if I understood the physics. If I understood the physics documentation correctly, it is in the local space of the first body that we can drive it around in. So, yeah, we can't use a raw input, the system we used previously for throwaway code, because raw input only works on the client. We need this to work on the server as well. But now that we are deriving from avatar tracking component, we can do get input, can't we? Get input something or other? No? I don't remember how this works. I haven't written C++ components in a while. I've written some rendering code for the web GPU things, but not really components. Yeah, so we have minput buffer. Yeah, here is where we can. This is get input or get action, get range, or get state. Yeah, right. So this input buffer here, this guy comes from basis avatar tracking component. It's protected. So cool. This is it. And I think we need to check if we have an input buffer, because if you are not an avatar, then you won't have this. And we shouldn't try to actually use it. Right. So if you have an input buffer, we need to read something. And they should probably just be states. And what should those states be? Well, this is a SIG project. For example, we have the means app struct here, which is in Zig, and we set up all the input here in Zig, in add inputs. And this is the stuff that we looked at previously. So we should really put in the inputs here rather than in the C++. So let's do that, and then let's just use them for C++ because we can still do that. So let's just set in some inputs here. So we have protocrane forward. I'm going to copy that. So protocrane forward, backward, left, right, up, and down. You can move it in any direction. And these are called protocrane because they're going to be thrown away. This is not how we actually want to move this crane, I think. But we'll have them here for now. And all of these guys are going to be states. So you can just essentially you can just ask the system, is this being active? Oh. Is this active right now, or is it not? It's not a range, it's not an action, it's just a state. And then we need to map them somewhere. and that is always the tricky part. Where do we map them? Where do we map them? Maybe we only map them to the keyboard for now. Just make things easy. So map keyboard input. Yes. This would be input ID. Proto crane. Forward was the first one. Basis input key code. We have numpad, right? So forward would be numpad 8. And we have the context, and the context would be input context ID, vehicle driving controls. Just mapping everything to the vehicle driving controls now, so that I don't have to mess around with the contexts. Backwards would be 2, left, right, up, and down. Right, so left would be 4, right would be 6, up would be 7, and down would be 9. That is a more or less nice way to control this crane now, temporarily. Unfortunately, this doesn't give me the numeric values now for these things, so I'm going to have to calculate them. But that's 256. So 257, 8, 9, 260, 1, 2, 3, 4, 5, 6, 7, 8, 9, 270, 271, 2, 3, 4, 5, 6, 7, 8, 9, 280. So 281, right? 281 is what we have. We can actually just put them here. If I got this correctly, this would be 281. And maybe we can actually just do something like this. What is that actually? Input buffer get state. So it's a game input ID, okay? Const game input ID would be 281. Like that. And we get them here. And we can just straight up use them as they are. Something wrong with the type there. Let's figure that out. What is that? That is probably the fact that we need it to be scoped to basis, right? No? Yes. We just probably don't have some input or include here. Let's see if we just do input and basis input, and now they go away, and now everything is good. Okay. Right. So, what would the speed for this thing be? For that, we can do something fun and create a hot value. So core hot value. And hot values are interesting because they can be adjusted on the fly through something called the monitor, which I will show you in a bit. So let's do float g crane speed. Crane. Let's do arm end speed. And it needs to be actually wrapped in basis hot value like this. And what were the parameters? So category, that's actually this bounded types, category label min value max. So we just write here proto type crane speed. Min is like very, very slow. Value is something a bit larger. And max can be like even larger still. Something like that maybe. And then we need probably actually we need a member here for holding the current position of the thing. So arm end position. And we'll set this arm end position to be to be this. So pos. Right, and now we can do this thing where we can do m input buffer get state proto crane forward. Then now that's C actually, plus equals let's do g speed arm end speed get times time dot tick delta time. And this is probably complaining because I don't have the input header, so input game input buffer, like so. And that would be minus, and this would be backward. And then we do essentially all of these things. So we have left, and we have right, and we have up, and we have down. Left is actually minus, like so, and that would be y and y. So, how about that? Will this work? So, I'm trying to move it around. Oh, I can't do that yet. One second. I need to build this first, because we added these things here and we need them to be mapped to the correct things. While we're at it, maybe I'll make this a little faster. So now it moves like half a unit per second. That seems like reasonable speed. Okay, so up, down. Oh no. Why? Yeah, I mean, you guys are probably shouting at me right now, like, what are you doing? What are you doing? But of course I need to actually call this thing. I need to call this thing, right? Oh, you know what? You know what? That should actually probably be initialized to 0. Yeah. Yeah, that should be probably initialized to 0, because this is not in relation to the object. It's in the relation to the joint. I think this should be, let's call this offset. And we'll just set offset to, well, this is implicitly already done, but we can do it anyway. Yeah. I don't know if we really needed to rename this, but now we did. Yeah, because 0, when it's at 0, it should be where it is kind of initially. So it's right there. And now if I move it, okay, I don't seem to be moving it anywhere. Is this actually running? Pre-tick. Needs pre-tick. Mm-hmm. 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 Can make this slightly more debuggable by enabling optimize off there. Okay, so now it runs, but it won't get in here. It will never get in there because it's not an avatar. And I know I know what the problem is actually. Probably. Maybe. Possibly. So in C++ you need to do a little bit more work to figure out how to actually use this avatar tracking component thingy. I think. Let's have a look here. Avatar tracking oh, actually, yeah. Yeah, my mind is just racing all over the place. Okay, so we are subscribing because it is subscribing to the correct places, but we're not doing this. We're not forwarding to the avatar tracking component when we receive a message, and that is what the problem is here. So we need to forward this like so. So the avatar tracking component can do its magic here. I forgot that because you don't need to do that in Zig. It's handled for you automatically. Right, so now we're running this code. That looks good. And we still can't do. Oh, we can. Okay, forward backward works. So that's interesting. It's a little slow, but we can adjust that. Why don't the other things work? So 180, 281, 282. Ah, okay, that's why. I bet some of you were screaming at me from home about that thing as well. And now, yeah, now we can move it around. Cool. Okay. Right, so how do we actually make this faster now? We start this program called the basis monitor, which allows us to do all kinds of like profiling and whatnot, and we connect it to the game. We adjust this from here, set it to like something like that, maybe even 2. 2 seems alright. Right, so now we can actually drive the vehicle and operate the crane at the same time, which is just scary as hell. So let's see if we can we actually like push ourselves now with this. I don't need to do any of that. I can just move the thing around. We can just I just go completely crazy with this. Yeah. All right, let's brake here, and I should be able to push myself against the ground, I guess, as well. Yeah. Hey, I can just turn the whole thing on its side if I want to. Woo! This is actually kind of interesting. I'm sensing some emergent gameplay arriving from this. And now we're... Oh no, we fell over. And now what you can do if you want to is you can just try to flip it back over again. Let's see. Controls are mirrored now because we're upside down. It's kind of tricky. Boing. Hey. And we are back. Okay, cool. Interesting stuff. Interesting stuff. And you can also probably... I don't know which vehicle will start rolling first, but again, at least in theory we should just be able to like push these guys around as well. And unless the physics is completely borked, which it may very well be, then the mother vehicle should stay in place, and this truck should start moving, but wouldn't bet on that actually happening. Yeah, that actually does happen, and we get a little bit of a like response. You can see the mother vehicle sort of moving a little bit. If we just move back and we let the truck settle so that it actually engages its handbrake, you can start to like push it a little bit. It's fighting. It's fighting. But eventually it will have to give. And we can even lift this guy up. And you can see again here the mother vehicle suspension is getting affected by all of this. Can we actually sort of move this guy using this? Can we lift it actually? It's much more fun than I anticipated. Oh man, we can't lift it. Why won't you lift? We need to give the mother vehicle more weight, it would seem. It's kind of interesting, like that. It would seem like the truck is too heavy to lift with this guy. Why would that be? I don't know. Yeah, I'm trying to lift this thing, but it won't allow me to do that. Won't allow me to do that for some reason. That is really interesting. Let's see if we can just make that happen. I want to lift that truck now. So it's the truck number 2, and it's sort of out of scale. It's kind of stupid. I should probably just remove it, but not right now. Now we're gonna figure this out. Okay, so its mass is set to 1. It is possible that we override this mass from the vehicle definition. I don't remember how it worked. Yeah, this is also just set to 1. So let's have a look here. Not there, but not there either. Actually, we can just use this. And means data, work folder, root, game, vehicle defs, mother vehicle, chassis mass is 8,000 kilograms. And that's set to 3,000. So why doesn't it actually allow me to lift it then? 1,500. Let's see if we can lift one of those scout vehicles instead. Because that is obviously like really important that we can do that before we start messing around with cables and whatnot. Let's actually just make that slightly faster by default. So we put it to 2. Yeah, like it is really important that we can actually lift those vehicles. Otherwise this thing doesn't really work out, and I will have to come up with something else. But this is game development. Game development. This is actually the fun kind of game development. Let's move this to the ground. There we go. There we go. There we go. Okay. It's sort of it's a little tricky to get in there. In between the wheels. All right. Something like that. Right. And now we lift. Hey. All right. Yeah. All right. Yeah, the joint is fighting the forces. Oh man. Oh man, this is scary. Let's drive around a little bit with this thing. I guess we found like just by accident, we found a pretty good size of body for actually lifting this kind of vehicle. And it fell off. Yeah, that's fine. Yeah, I wonder why that thing is so difficult to lift. It's not necessarily a problem. We just need to tune some values. And like I said, that vehicle is kind of out of scale anyway, so let's move this thing down so that it hits the ground, so about there. And then we'll add on top of it. We'll add a right. So that's a truck number 1, right? It's called truck 2, but that's just its name. Its type is vehicles truck number 1, and this is actually a truck number 2. Yeah. Okay. So with this now, and everything is just mirrored and weird. Let's figure out the rough center of the thing. Maybe somewhere there. Let's see if can we lift this now. And you can see that mother vehicle reacting, and yeah, we can. That's fun. And the joint is just, oh, it's fighting it so hard. It's almost falling off already. Let's try to put this onto the mother vehicle. Can we do that? Just lift it on top of it. Oh shit! No. No. We can save this. Go down. I need to position my camera. It's so difficult to see with just these debug visualizations that what goes where. But now we're under it. Now we can just lift it up. Come on. Up you go. Up you go. Here we go. Hey. All right. Yeah. Okay, so this, I would say that this seems to work. It's not supposed to be this difficult to do it, but when we add the magnet, we could add the magnet just directly to that object. But I think it's much more fun to add the cable there. So maybe we'll do that. Maybe we'll try to add the cable there and see what happens. We should also get some really interesting swinging behavior. Swing when you're winning. Yeah. Okay. Cool. Let's end this part here. Let's try to get the cable and the magnet working in the next part with this prototype crane thingamajig, and then perhaps after that we'll, if it still works as well, we'll start looking at actually moving this over to Zig, exposing all the joints and everything. So cool. Hope to see you in the next one. Bye.